Good morning. Today we are going to learn about the properties of logarithms, and these are going to tie directly into the properties of exponents that we talked about a few lessons ago. The reason is logarithms are like how you undo a problem that has exponents in it, how you figure out a missing exponent. And so since they are inverse operations, the same properties are at play. So we're going to see that today. And this is a very exciting day because I have a helper today. I want you to meet Lenny. This is Lenny the lizard, and he is a logarithm expert. In fact, you could call him logarithm wizard lizard. So he's going to help us today. Remember that logarithms tell us exponents, aren't you, Lenny? Okay, so I want to recall this foldable that we used a few days ago. And in this, if you have a logarithm, what does it equal over here? Do you remember? Can you look and see? An exponent. Logarithms tell us exponents. When you evaluate a logarithm, you get an exponent. So that is the key idea for today. Oh, what I have up here on the screen is our rules of exponents that we have written down from a little while ago, because we're going to connect those over to the rules for logarithms. So if you want to just pause this and get those all written down right now, that's fine. We'll wait on the change of base property. I'm not going to mention that in today's lesson, so we'll mention that tomorrow. But the other ones we'll talk about today. So what was I going to say? So a big idea for today is that logarithms tell us exponents. Logarithms tell us exponents. So let's decorate that idea a little bit, shall we? Let's see. Come on. Oh, this one. Snow. And happy faces. This is the main idea for today that will help you make the connection between these logarithmic rules and the exponential rules that you already know. We're building on that prior knowledge. So logarithms tell us what? Exponents. So good job. So let's see. Let me go back to my page of rules here. Okay. So first of all, let's look over here on the left where we have the product of powers rules for exponents. So if you recall, when you have a problem like this, mark that. We have a problem like this, like the x squared times x to the third. What you do is you keep that base and you add the exponents. Okay, so that was our rule for products. Okay, so when you see multiplication, you keep that same base and you add the exponents. So over on the left, it's right here, is where we're going to look at the product property for logs. So we're connecting the product property for powers with the product property for logs. So what does a logarithm tell us? An exponent. Yes, logarithms tell us exponents. So if we look right here, that tells us an exponent. And log b of n, that tells us an exponent. Logarithms tell us exponents. So what we are doing with those, look between those two red clouds there. Do you see that little plus sign? We are adding the exponents. Now think back to the exponent rule side of things. When do we add exponents? Well, we add exponents when we are multiplying. So we can take these two separate logarithms and write them as a single logarithm. Notice we're keeping the same base. The base was b. That's important. You have in the left side of this problem, we have log base b in both of these. and we are adding these logarithms. So in effect, we are adding the exponents. So that means we must be multiplying. So look here on the far right of this. We've written this as a single logarithm, the logarithm base b, so we keep that same base. And since we're adding the exponents, we must be multiplying. So right here, you see us multiplying the m times the n. That's the arguments. I don't know if you can see that because I kind of drew over it. The m and the n must be multiplied if we had to add the exponent. So it's taking the exponential rules and using them in reverse, okay? So that is the product property of logarithms. Let's go ahead and do an example of that, I think, right now while we're thinking of it. So let's say I have log base, log base 5 of 7, and I'm adding log base 5 of 11. Okay, so if you look at this, first check and see if you have matching bases. You have to have matching bases to use any of the logarithm rules, just like you had to have matching bases in any of the exponential rules. Okay, so we do. If you look at these 5s here, they match. So now, what does a logarithm tell us? An exponent. What does a logarithm tell us? An exponent. So we are adding exponents here. When do you add exponents? What exponential property is at play when you add exponents? Well, that's the product property. So we can write this as a single logarithm, log base 5, and we can write the product of 7 and 11, which would be 77. So there we've condensed it down into a single logarithm. That'll be important when we get to solving equations with these. So right now we're working with simplifying things, and then we'll solve equations in the future. So there's the product property. So let me go over to our property screen again. Here we go. So erase that. Let's talk about the quotient rule next. So when you have a quotient of powers, so I'm looking right here on the left, quotient means dividing. So you see a division problem in this example right here. X to the 5th divided by x to the 3rd. What is it we do with those? Well, we keep that same base and we subtract the exponents. Okay, you see that in the rule right here. Keep the same base and subtract the exponents. So let's connect that over to the quotient property of logarithms. So what does a logarithm tell us? An exponent. So right here, that logarithm base b of m would be telling us an exponent. Logarithm base b of n would also be telling us an exponent, and we are subtracting those. So if we're subtracting exponents, it must be the quotient rule that's coming into play. So if you look here on the far right, we've taken those two logarithms. They both have the same base, b, that's the little subscript number, and we've written them as 1. And since we must be dividing, if we're subtracting the exponents, the m and n, oops, I don't know if you can see that. Oh, I'm not writing. Right here. The m divided by n is there because we're taking our two arguments, which I kind of wrote over here. See that m and that n, that those are the arguments? I must be dividing them if I had to subtract the exponents. So we're consolidating these things. So let's see what that would look like in an example. Let's just get a new page here. So let's say I had log base 3 of, I don't know, 50 minus log base 3 of 2. So here's how you look at this. You say, oh, I have a logarithm. What does a logarithm tell me? An exponent. Oh, I have another logarithm. What does a logarithm tell me? An exponent. So I am subtracting exponents. When do I subtract exponents? In the quotient rule. So I can write this as a single logarithm. So I'm keeping that same base. And quotient means I need to divide. So 50 divided by 2 would be 25. So I've divided those. That's the quotient rule in effect. So, all right, let's see what our next rule says. Let's see. Let's look at power to a power. So I'm looking right here on the left, power to a power. And this is when you have exponents stacked on top of each other. So we have an x squared that's getting raised to the third power. And you keep that base and you multiply those exponents. So let's connect that over to what it would look like in logarithms. So I have a log base b of m right here. What does the logarithm tell us? An exponent. And we are multiplying. Oh, I kind of drew over it, but do you see how this is getting multiplied by the n? Let me erase the rest of that. Oh. Erase. So the logarithm here is telling us an exponent, and we're multiplying, which means this n must be an exponent. So what we do is we take that exponent, that n, and put it back up in its rightful place as an exponent. See how it becomes m to the n power there? So that's the power to a power property of logarithms. So let's see what that would look like. Oh, let's just do it in the page. So if we have 2 times the log of, I don't know, 7. Now, you might think, oh, Mrs. Freeze forgot something here. She didn't tell us what the base is. Silly Mrs. Freeze. Actually, I didn't forget because there's a base that we assume is in play if we don't mention any other base. What's the base that's like the most common number that we use or this base system in our place value? 10. Okay, so if it helps you to put it there, go ahead. But I didn't forget. So what does a logarithm tell us? An exponent. So we are multiplying, which means the 2 must be an exponent. So we're going to take that and we're going to write it in its rightful place. So the 2 is going to become the exponent on the 7. So that's how you consolidate that. Oh, and then we can go ahead and just figure that out. That would be 49. So you could say that this is log base 10 of 49. So that's how we simplify that. So, okay, let's see what the next one is. Oh, that was supposed to erase. Okay, so the next one is negative exponents. Let's see, do I have one that ties into that? Okay, so now I have to talk about the definition properties of logs, which are up here at the top. So if you look right here, these are the ones I'm going to be talking about now. There's 3 of them listed in this box. And the definition properties are kind of like, well, yeah, if you think about them. So let's look at, let's look at this one first. It says log base b of b equals 1. Okay, log base b of b equals 1. So what that means is, let me grab a pen. So I'm going to use my little log foldable here. You can do this if you would like. Log base b of b equals 1. So let's use this and convert it to exponential form so we can connect it over to exponential rules that we already know. So what number's the base? That would be this b here. What's the exponent? That would be the 1. And what's the argument? That would be the b. So if I took this and wrote it in exponential form, I would say b to the first equals b. Well, does b to the first equal b? Yeah. So it's kind of like, okay, yeah. The reason is if the base matches what your answer is, so the base is the subscript number, and you can think of the argument as your answer to after you figured out this exponential problem, it must be an exponent of 1. If b to the something equals b, well then yeah, you're only using an exponent of 1. So that ties into, well, I don't have a rule that this ties into. It's just the idea of if I don't put an exponent, the understood exponent is a 1 on it. So there's that. Let's talk about this one next. Log base b of 1 equals 0. So log base b of 1 equals 0. So I'm going to take that and write it in exponential form. So what's my base? It's b. Let's see. What's my exponent? It's 0. And what's my argument? What's it come out to? That would be 1. And this says that b to the 0 power equals 1. Well, what's anything to the 0 power? It's 1. So that ties into our 0 exponent rule over here. In our example, we have 2 to the 0 equals 1, but anything to the 0 power equals 1. So that means if you have to take a logarithm and the argument is 1, the exponent that gives you that must be a 0, regardless of what the base is. No matter what the base is, if you see a 1 in the spot of the argument, then that logarithm, since the logarithm tells us what? The exponent. That means the exponent must be 0 to give you an answer of 1. So that's how those tie together. And let's talk about this last one. Erase that. So this one right here. So it's definition 1, so it's kind of like, well, yeah, that makes sense. If I take this what's the base? That would be b. What's the exponent? That would be m. And what's the argument? That's right here. That would be b to the m. So b to the m equals b to the m. Well, yeah, it's kind of obvious, right? So here's what this says. If your base and your argument base match, then it's just going to cancel those things out and just give you the m. So let me show you what that would look like. If I have log base 4 of 4 to the third, taking the log base 4 of an argument with a base of 4 will cancel each other out. That would just equal 3. So let me show you another one. If log base 7 of 7 squared is what I'm figuring out, so I'm taking a log with a base 7 and my argument has a base 7, those two things undo each other. They're inverse operations, and that gives you just a 2. So that's how you simplify if your argument also has a base in it. So the argument here is being written in exponential form so that you can see that they match. So that's that. Let's see. I think I would like to do some sample problems with you on delta math from these. So let's look that up real quick. I'll just kind of go through some that you might be seeing today. Let's see. It is, which one are we doing today? Logarithm Properties. That one's it. Okay. So let's say we had this. Okay, so I see logarithms, and what do logarithms tell us? An exponent. So this tells us an exponent. Oh, I can't write on the screen. Let's see. Let me paste this problem over here real quick. There. Oops. So this logarithm tells us an exponent. Oh, shoot. Let me back up. I didn't realize I had an X in front here. Okay. Pause. Rewind. So when I look at this problem, I should pay attention to the order of operations. I should always watch that. Got too excited. Didn't think about it. So I see this logarithm back here is getting multiplied by an x. Okay, so if you look right here, this logarithm is getting multiplied by an x. Well, what does that logarithm tell us? An exponent. When do we multiply with exponents? When we have power to a power. So this x must be an exponent. So I'm going to move it back up to its rightful position up here. Okay, so that's how I simplify this back part of the problem. Now let me bring the plus log d over to. Oh, what's the base on these? Did we forget the base? No, it's an understood 10. So you have log base 10. So since they both are log base 10, that's why we're allowed to work on combining these things. So what does the logarithm tell us? An exponent. So this is an exponent, and this logarithm's telling us an exponent. And look what we are doing with those two things. We're adding them. When do we add exponents? What exponential property makes you add the exponents? That's the product property. So I can write these as a single logarithm, log base 10, of d times g to the x. So notice on delta math, the log part is already there for you, so you just have to type in d times g to the x in order to answer that. So there's that. Let's look at one of each of the types. So expanding logarithms. Okay, so this, we're going to take this thing apart. So we can use these logarithm properties to put them together, or we can use them to take them apart. Okay, so I have, I gotta do a screenshot real quick. Okay, so I have log base 10 of 8x squared. So log base 10 of 8 times x squared. Okay, so this is my argument. What do you see happening in that argument? Well, we see some multiplication happening. So if I'm going to split this up, what am I going to need to do with the exponents? So if this is the product property, because there's multiplication, that means you have to do what with the exponents? You have to add them. Well, the logarithms tell us the exponents. So to break this apart, we're going to write this as 10, log base 10 of 8 plus log base 10 of x squared. So now think about that in reverse for a second to make sure you're understanding what's going on. A logarithm tells us what? An exponent. So here's an exponent, and here's an exponent, and we're adding those. which means it must be the product property because that's when you add exponents. So that's what this multiplication in the argument is there for, because it's the product property. So let me get rid of some of that writing. Okay, so I've got this part on the left down to just a single logarithm, but this part on the right, I'll mark it in blue, it has an x squared as its argument. So it's still a little bit complicated. So I'm going to see if I can break that down. So we have a power here. So this 2 is a power. So what do we do in the power to a power property? That's when you multiply the exponents, right? So the logarithm tells us what? An exponent. So I'm going to write this as log base 10 of x, and I need to multiply it by the other exponent, which is the 2. The logarithm tells us an exponent, and the 2 is obviously an exponent. So we're multiplying those exponents because it's a power to a power situation. And then I'm just going to bring this down. Log base 10 of 8. Oops, that's an 8. So there's that. Go back over here. Let's see what this one looks like. Oh, this is more just expanding them. Okay, so screenshot that. Pull it over here. Okay, so here's our problem, and we want to expand it fully. So I see the 9 is getting multiplied by an x to the 5th. Let me write it over here. Log 9 times x to the 5th. Okay, so I see multiplication within my argument. So that means the product property is coming into play. What am I going to do with my exponents in the product property? That's when you add them. Well, logarithms are what tell us what? The exponents. So this is going to be log of 9 plus log of x to the 5th. So I'm adding the exponents because it was a product. Okay, that's how you decompose this thing. So this logarithm is as simple as it gets. But this one I can do some simplifying with because my 5 is still an exponent. So when you have a power to a power, you multiply the exponents. So this 5 is going to get multiplied by the logarithm because logarithms tell us what? The exponents. So log of 9 plus, so the log of x is an exponent, and I'm going to multiply it by the 5 because it's also an exponent. So I'm multiplying the exponents is what's happening here because the logarithm tells us an exponent. You can kind of think about it as this, that the 5 moves out front and gets multiplied. So there we go. So there's some to get you started. Let me know if you need help, and remember that Jesus loves you, and so do I, so do your math.